Yes, good morning once again. This morning, we'll briefly talk about the topic risk and uncertainty. So I forwarded a video of the normal classes to a platform for, for those that don't have period background of this topic to watch and know what it entails. So questions on risk and uncertainty, um, I would say they are not difficult, but there is one thing I've discovered that is not in our textbooks, and that is what I would like to emphasize today. Like especially on the question of the local football club. Over time, over two diet or three diets ago, so most students find difficult to solve that question, and I know I can will definitely repeat that question one day again. But it's a very um, simple question if you know the logic behind it. And I've looked at the question again, even though I have various versions of my solutions to that question. But this morning, I will present a very um, simple version of my solution on that question. So, but there are certain things I will explain that you have to know whenever you see question on risk and uncertainty. Is not in the other video I forwarded. These little highlights I'll put forth this morning and not in the other video. So, and in that question, there are phrases that you must know the interpretation. I will want to repeat and reiterate again that English language is very important when trying to solve ICANN questions. So you must read line by line and be able to interpret what questions, what's each word saying. So just a brief background of the topic risk and uncertainty. Risk I will define as situations where the possible outcomes are known and probabilities can be assigned to them. Now, when you are engaging in a risk, it means that there is a probability of you winning or losing. It means that there has been past occurrence of similar situation, and then you can actually predict that yes, I will I will prevail or the reverse will occur. That is risk for you. For example, a very clear example, sorry to use that, is the issue of football. Yes, that's the probability of Man U winning Arsenal might be might be 0.5. That is uncertain. The probability of Arsenal overcoming Man U can be 1. That is a prediction now. Now, how do you come about that? In football, there's what they call head to head. Sorry, I'm not a football fan. I just follow them on Facebook and know what is happening. I don't have time to watch football. But in order not to be left outside what is happening, so once in a while, I I follow on Facebook and see what they are saying. So the in football, there's what they call head to head. That is past occurrence. That is maybe Arsenal, how many times Arsenal have played with Man U, and how many times winning have occurred between them. Yes, these are past events. So on this premise, you can now make a prediction. So for those that do betting, when they put their money, they are taking risk. So the probability of Arsenal winning Man U There's what they call odd. Yes, it's what they call odd. That the odd is high, the odd is low, things like that. So probability of Arsenal winning Man U, when you predict, you are predicting based on the fact that you have past record. So you are taking risk. So risk refers to situation where the possible outcomes are known and probabilities can be assigned to them. For example, most of you play Ludo. Yes. So in a dice game, you know the outcomes. When you throw a die up, you know the outcome. Guys, the outcome can range between 1 to 6, and each has a probability of 1 over 6. So also, when you want to invest, you may know there is 20% chance of losing your money and 80% chance of gaining. There's a question I discovered some people post on the platform. A question
Hello, good morning, sir. Hello, good morning, sir.
I think he said on the group that he lost his network. Maybe we should just hold on to him.
Hello, can you hear me?
Yes, I can hear you. Good morning, sir.
Yeah, we can hear you now.
Okay, sorry
Yes, we
for the
can hear
break.
you.
All right, sorry, lost connection. So I've explained what risk is all about. So talking about uncertainty. Uncertainty refers to situations where the outcomes are unknown. Take note, risk, at least you can predict the outcome. For uncertainty, the outcomes are unknown. Maybe you are the first to venture into that kind of business. Means um, the case is a case of uncertainty. Uncertainty. So one thing with uncertainty is that probabilities cannot be assigned with confidence. In uncertainty, probabilities cannot be assigned with confidence, but with risk, you can assign probability. Now, example of risk is you launching a new product in an unfamiliar market. So you don't know exactly how consumers will react when you introduce that product. What you're engaging in is uncertainty. Also, you can have a case of political changes. That is, the impact on policy and economy may be highly unpredictable. So when we have such situation, we are facing uncertainty. So the key features of uncertainty is that probabilities are unknown and unreliable, and more so, outcomes are ambiguous and can be entirely new with uncertainty. So it is very difficult to manage uncertainty than risk. So this often requires judgment, experience, or scenario planning. That is the case of uncertainty. So based on this slide, I said decision making involves making decisions now which will affect future outcomes, which are unlikely to be known with certainty. So risk exists where a decision maker has knowledge that several possible outcomes are possible, usually due to past experience. So this past experience enables the decision maker to estimate the probability or the likely occurrence of each potential future outcome. So uncertainty exists when the future is unknown and the decision maker has no past experience which on which to base predictions. So whatever the reasons for the uncertainty, the fact that it exists means that there is no rule as to how to make decisions. So for the examination, you are expected to be aware of and to apply several different approaches that might be useful in the case of a question. So we have what we call risk preference. Risk preference means your attitude towards risk. Your attitude towards risk. We have those that love risk. When they see risk, they smile, they dance, they embrace risk. We have those that detest risk. When they see risk, they run. We have those that are indifferent to risk. Whatever happens, it's fine to them. Yes, they are indifferent to risk. So this is an approach taken to make decision, and it depends on the decision maker's attitude to risk. So a risk seeker will be interested in the best possible outcome. So a risk seeker will most likely give all he or she has to a project, not minding or with the mindset that the outcome will be favorable. So this is an optimistic approach. A risk seeker will always want to give to a project with the hope, they are always optimistic, with the hope that the return will be favorable. So that is a risk seeker for you. So someone who is risk neutral will be concerned with most likely or average outcome. So somebody who is risk neutral, no matter the addition to the investment, no matter how insignificant it is, they are always very fine. They're always very fine with the outcome of the risk. While a risk avoider makes decision on the basis of the worst possible outcome. Risk avoider will just, let me just put small of my investment, because the stock price can fluctuate. Anything can happen. So let me play a defensive game. Yes, that is a risk avoider. A risk avoider. They don't embrace risk as much. It's very difficult to convince them to take risk, because some of them, due to past experience and limited resources at their disposal, might not want to risk that little resource and end up not having anything in return. So yes, talking about risk and uncertainty, there are various approach to evaluating risk. There are various approach to measure risk. And one of the approach is the use of average rate of return, the use of payback period, adjusted cost of capital, the use of expected value approach, mean variance analysis, and the use of sensitivity analysis, simulation technique, decision tree analysis, certainty equivalent approach, and the rest of it. What the subject matter of this class is to see how we can analyze risk using triple assessment method. And when I talk about the triple assessment method, I'm referring to the issue of maximas, maximum, and minimas regret. Maximas, maximum, and minimas regret. Now, please, you can put down or take down notes. So I think the Gemini is taking down the notes anyway. So it's better you have it handy to yourself. So when we talk about maximas, maximas, let me see if I have it here. Yeah, maximas decision rule. Maximas decision rule. What does this entail? From the word maxi, mass. Maxi, mass. Take note, there are two words now. Trying to explain this in the form that there are two words. Maximax. Maximax, yes. What does this connote? It means you choosing maximum of the maximum. Choosing maximum of the maximum among range of possible outcomes. It means when you have options to make, you have a project A, B, C. Now, among project A, B, C, what are the highest expected return? If the highest expected return for project A under a situation of bad economic condition, under a situation of good economic condition, if the best return for project A is 100, and the best return for project B, likewise, under various economic condition, is 80, and for project C, the best outcome under C, project C, is let's say 60. So you bring out all these best outcomes for each project. Now, out of this best outcome, which is the maximum among the various arrays of outcomes? So maximas involve selecting the alternatives that maximizes the maximum payoff achievable. That is Maxima's decision rule. When you want to make a decision, so among the various options you have, select the maximum. When you select the maximum, you now still filter among the maximum, which is the maximum. So that is choose maximum of the maximum. That is maximus. So this is suitable for an optimistic investor who wish to achieve the best result if the best happens. Yes, means you're giving out your all, hoping that the best will happen. Means you're optimistic that yes, it will yield a favorable outcome. So hence, Maximus decision rule suits such kind of fellow. So take note, max, it means maximum of what? Maximum. Maximum of maximum. Based on this slide, I said this is a decision rule based on the view that decision maker should select the course of action with the best possible payoff, such as the highest possible profit. So this approach is based on the view that decision maker should seek the highest return, assuming that events turn out in the best way possible. So the maximal decision rule can be described as a decision rule for the risk seeker. Yes, for the risk seeker. Now we have what we call the maximin. 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 Sometimes students get confused with all this. So I'm trying to make it clear now. Maximus, the best among the best. Yes, so maximin now. These are two words again. Let me break it down. Maximin. 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 It means in this word maximin, you have two words. I'm putting it that way. You have maximum, you have minimum. It means that you choosing the maximum of the minimum. Now, among range of possible outcomes, you choose the minimum. Among the minimum, you still have a maximum. Yes, among the minimum, which is the highest. So maximum is you choosing the maximum of the minimum. That is selecting the alternative that maximizes the minimum payoff achievable. That is maximum of minimum. Means if in project A, if the minimum value is 20, project B, the minimum value is 30, project C, the minimum value is 40. Out of this minimum value, which is the highest? Project C, 40. So that is maximum. Maximum of minimum. Maximum of minimum. That this decision rule is based on the view that decision maker will identify course of action with the highest expected return under the worst outcome. Yes, among the worst outcome, which is better. So the choice is based on trying to maximize the minimum possible profit. So this decision rule might be associated with a risk-averse decision maker. So also we have what we call the minimus regret. Minimus regret. Minimus regret. What does this entail? The minimus regret. Minimus regret. This is the strategy that minimizes maximum regret. Yes, it is the strategy that minimizes that maximum regret is suitable for risk-averse investor. Now, among regrets, when we talk about regret, it means the opportunity costs of not getting the highest outcome among range of course of actions. For example, in project A, if the highest profit is 100, but the highest profit is not forthcoming, let's assume there's an opportunity cost of putting it off. You use the highest profit, you subtract the highest profit from every other possible outcomes. Now, the worst outcome among those options, you fish it out. Now, based on various projects, the worst outcome, that is the opportunity cost of not getting the highest outcome. What is the result? Is the minimalist regret. So regret is the opportunity loss through having made the wrong decision. Since you didn't make you made the wrong decision, you lose the best profit. Since you lose the best profit, what is the minimum regret you have? What is the minimum regret you have? So for you to determine minimalist regret, you choose the maximum from each of the column. The maximum from each of the column. If you've watched the video I forwarded, I've explained all this. You choose the maximum from each of the column. Let me see if I have it here. You choose the maximum from each of the column. Then when you do that, you subtract the maximum from every other element in the column. You subtract the maximum from each other element in the column. Then you choose the minimum of the regret. You choose the minimum of the regret. So when you choose the minimum of the regret, out of various course of action, which is the least regret? Which is the least regret? So that will be your minimalist regret. That will be your minimalist regret. Now, very quickly, what is a payoff table? What is a payoff table? When we talk about payoff table, what do we refer to? I want to quickly talk about this because in every question, you see prepare a payoff table. And even the question we'll be looking at will ask us to prepare a payoff table. What is a payoff table? It's a table that illustrates all possible profit or loss or possible outcome. So a payoff table can also be called profit table. Profit table. So it is a useful way to analyze range of possible outcome. Range of possible outcome. Now, when it comes to risk and uncertainty, how do you determine your profit? How do you determine your profit? I'm gradually delving into the question, but before we go ahead to read the question, I want to explain something so that when we read, we'll read with understanding. So now, to determine profit in risk and uncertainty, anytime you see any question on risk and uncertainty, prepare payoff table. What do you do? The point is this. Determination of profits or loss. Now, how do you determine profit? How do you determine profit? Profit is equal to what? Profit is equal to total revenue minus what? Or let me put it this way. Total revenue, yes. Let me say plus scrap value. Scrap value, yes. So scrap value minus the total fixed costs minus total variable costs minus costs incurred. Cost incurred on disposal. Cost incurred on disposal. So this is how you determine your profit. Now, when we talk about revenue, total revenue, what are the elements of total revenue? Total revenue. Please, this concept, even beyond risk and uncertainty, as you approach the exams, you need to break down questions in this order, because you see questions that requires you to determine revenue, and sometimes they will give you the value of revenue in units. They'll give you units, they'll give you selling price. So you must be able to break questions down in in this order. So the value of total revenue or the components of total revenue is what? How do you determine total revenue? It is your price multiplied by what? By quantity. By quantity. Price multiplied by quantity. Also, when we talk about total variable cost, total variable cost, total variable cost. I'm not talking about fixed cost, because fixed cost will always be in lump sum. Total variable cost. Total variable cost. How do you determine that too? It will be variable cost per unit. Variable cost per unit multiplied by what? By unit. Yes, by unit supply or unit produced, whichever. Yes. So now, this is a breakdown. Now, what is scrap value? When we talk about scrap value, why is scrap value coming here? Why is scrap value coming here? You know, sometimes when you produce goods and you didn't sell everything, you can decide to sell the value or the good at a scrap value. That scrap value is an income, below the actual selling price. Is an income below the actual selling price. Now, why is cost incurred on disposal coming here? Cost incurred on disposal. Sometimes some of the goods we produce, if they expired and they are harmful to the environment, you need to incur cost to dispose them. You need to incur cost to give to scavengers. You need to incur cost to burn them. So that cost incurred on disposal is an expense and you need to less it. This concept is in relevant costing. Relevant costing. So when you are solving relevant costing and you see cost incurred on disposal, it is a burden on the organization, not an income. Take note of that. Students used to make that mistake when they see cost incurred in disposing the asset, since it does not have any useful, it is no longer useful in any division of the organization. That cost is a burden to the organization, not an income. Take note of that. If you watch one of the videos on relevant costing that we treated during the normal classes, one of the assignments I gave on Mr. Smith, yes, Mr. Smith, yes, there is a word there, cost on disposal. Students were misinterpreting that word. So anytime you see cost incurred on disposal, is not an income to you, but a burden, and which is an expense. So scrap value, you all know that you are doing CR, you've done I said CR, you're doing FR, but you do CR soon. Come by grace of God next diet, but it has been changed to SBR. So if you're doing FR, you should know what scrap value is all about. Even from your normal secondary school days, you should have known that scrap value is the estimated value that an asset will have at the end of its useful life, when it is no longer usable for its original purpose and is to be sold or disposed of. So another word for scrap value is what? Is residual value or salvage value. So the point is this: for risk and uncertainty, how do you determine your profit? The total revenue plus scrap value minus total fixed cost minus total variable cost minus cost incurred on disposal. Where these variables are available, where they are not available, you work with what is given in the question. You work with what is given in the question. Take note of this. Take note of this. Yes, let's now see the question. Let's now go straight to that question. Let's see. Let me change what I'm sharing. Yes, somebody can read among the co-hosts. as I try to change my slide. The question on local football club. You can read. Anybody there? Chikodili. I think the co-hosts are not available. Okay, sorry, let me just yes, Olamilekan, can you do you want to read? You can read.
The local football club has asked for your advice on the number of programs that should be printed for each game. The cost of printing and production of programs for each game, as quoted by the local printer, is 1 million plus 400 naira per copy. Advertising revenue, which has been agreed for the season, represents 800,000 for each game. Programs are sold for 150 naira each. A review of sales during the previous season indicate that the following pattern is expected to be repeated during the coming season of 50 games. Number of programs sold, number of games. Under number of programs sold, for 10,000, number of games is 5. For 20,000, number of games is 20. For 30,000 programs sold, number of games is 15. And the last one, 40,000 programs sold, 10 number of games. Programs not sold at the game are sold as waste paper to a paper manufacturer at 100 naira per copy. Question: assuming that the 4 quantities listed are the only possibilities, you are required to A. Prepare a payoff table. B. Determine the number of programs that will determine the highest profit if a constant number of programs were to be printed for each game. C. Explain why you should buy 30,000 or 40,000 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. D. Calculate the profit which would arise from a perfect forecast of the numbers of programs which would be sold at each game. E. Discuss the major limitation at expected value criterion in decision making.
All right, thank you very much. Yes. So looking at this question, there are various cost elements here, but the cost elements are silent. So you need to look with a deeper eyes and understanding for you to know the meaning of these cost elements and for you to know what they stand for. For example, the question that the cost of printing and production of programs for each game. Take note, the word each game is different from program sold. Each game is different from what program sold. Now, the cost of printing and production of programs for each game, as quoted by the local printer, is 1 million naira. 1 million naira. What is the meaning of this 1 million naira? That irrespective of the game, of the number of games, there will be 1 million naira incurred. 1 million naira will be incurred. It means the 1 million naira is a fixed cost because it's a constant amount paid to the printer, regardless of how many copies are printed. Take note of that word. Take note. This 1 million naira is a fixed cost, irrespective of the program sold, irrespective of the program produced. So the question explicitly states that the 1 million is charged for each game, regardless of whether the club prints 10,000 programs or 40,000 programs. So to the printer, it is likely to be a setup cost or an administrative fee from the printer for preparing, let's say, materials, designs, logistics, and the rest. So the 1 million remains constant per game, independent of the number of units printed. So please, that 1 million naira, that the cost of printing and production of programs for each game, as quoted by the local printer, is what? 1 million. Then I say plus 400 naira per copy. What is the interpretation of this 400 naira per copy? The 400 naira per copy.
Variable cost.
Very good. Variable cost. Variable cost. Yes, it's variable cost because it varies with the number of programs. Yes, that will be produced. That is the variable cost. Variable cost. Now, there is something again that is constant, irrespective of the number of programs. That's advertising revenue, which has been agreed for the season, represents 800,000 for each game. Advertising revenue for the season, it has been agreed for the season, not based on programs. Yes, it has been agreed for the season. So the advertising revenue is a guaranteed revenue, irrespective of the number of programs sold. Now, advertising revenue, 800,000 for each game, is agreed for the season. This phrase now, the phrase agreed for the season, suggests that contracts with advertisers have already been signed. So committing them to pay 800,000 per game. That is the interpretation of that. So it is not linked to sales performance. That is how many programs are sold. No, it is not linked to it. Since advertisers are paying for visibility or brand presence in the program, maybe there's a page for them to advertise. That has been agreed. So the club will always receive a full amount, whether 10,000 program is printed, or 40,000 copies are sold. So the 800,000 is guaranteed income per game. So a fixed inflow will always accrue to the football club, regardless of actual program demand. So that is one of the things with this question. So based on the question, let me just do a quick summary of the whole write-up. This question is a decision problem. The football club is trying to decide how many programs to print for each game in a 50-game season. So the cost structure is this. The cost structure in this question. The fixed cost per game. Please take notes. Take notes. The fixed cost per game is 1 million. This is a constant amount paid to the printer, regardless of how many copies are printed. The variable cost per copy is 400 naira. This is paid for each program printed. This is paid for each program printed on top of the fixed cost. So the total cost there will be 1 million plus 400 naira multiplied by the number of programs you want to print per time. If you are printing 10,000 programs, 400 multiplied by 10,000 programs will give you the total variable cost plus the fixed cost there. So also, in terms of revenue, we're talking about the cost structure now. In terms of revenue, sales revenue, each program sold to fans will generate how much? Each program, 150. 150 naira. From the question, is stated clearly. Advertising revenue, the club earns what? 800,000 per game. from advertisers. So this is guaranteed. So it doesn't depend on the number of programs sold. So also in terms of revenue, we have the scrap revenue. The revenue from the scrap, the unsold program. Let me put it that way, yes. The unsold program, the revenue from unsold program. So any unsold programs are not wasted. They are sold to a paper manufacturer as a waste paper at what? 100 naira each. So this partially recovers cost of printing. So instead of losing 400 naira, at least we're able to recover 100 naira. Means we are losing 300. We're losing 300. So if you look at this question again, the demand is uncertain. The actual number of programs that will be sold in each game is uncertain. But past data provides that a probability distribution can be seen. Now that a review of sales during the previous seasons indicate that the following pattern is expected to be repeated during the coming season of 50 games. Now, we have number of games, we have number of programs. Now, there's a probability game here that if we should have 5 games, what is the probability of which selling 10,000? If we should have 20 games. So how do you determine the probability at this point? So how do you determine the probability at these points? So let's go to the workings. I know some of you have seen some workings. I'm not working based on what you have in your Pathfinder, but we are arriving at the same point. Yes, because the Pathfinder didn't actually explain in details. So they just put some figures for you to be cracking your head and you're imagining how did they arrive at these figures. So just follow what I'll be doing. Don't open your Pathfinder and be checking. After everything, you can go and check and see what has happened. So let's see. Let's work out the probability before we go to the cost issue. I believe you should be able to do that. Let's see. Probability. So we have programs sold. Now, some people don't know how to get that because it was not shown in the Pathfinder. Number of games. If you have a question, just type it there. I'm not looking at I'm on my raw sheet, so I'm not seeing you. Probability. So the program sold, we have 10,000, we have 20,000, we have 30,000, we have 40,000. The number of games, we have 5 games. We have what? We have 20 games, we have 15 games, and we have 10 games. The total number of games give us what? The total number of games give us 50. So the probability of we selling 10,000 programs will be what? Will be 5 divided by 50. Should give us what? 0.1. Probability of we selling 20,000 programs will be what? 20 divided by what? 50 will give us what? 0.4. Probability of we selling 30,000 programs will be 15 divided by what? By 50. We have, please confirm, because can be some. These will be 10 divided by 50. We have 0.2. When you add everything, this is you should have 1. Yes. When you add everything, you should have 1. So that is that for that. So what does this connote? This tells us that demand can vary significantly and there is risk of overproduction. Yes, when there is overproduction, it means there will be programs that will be unsold. So, and these.
Sir, please, we are not seeing your screen. We not see the working. Everybody in the class.
Okay, sorry about that, please. Sorry about that. Can you see it now? So can you see it now, please? All right, thank you. Sorry about that. I didn't change my slide to my co-host should have informed me so that and sometimes I'll be carried away by doing the talking. All right. So the question is telling us to do what? I should prepare payoff table, right? Let's see what to do now. To prepare payoff table, we compute profit per game. We compute profit per game to prepare payoff table. You know, I earlier defined payoff table as a table that illustrates all possible profit or loss. That it can also be called profit table. That is a payoff table. So to prepare payoff table, we have to compute profit per game. Profit per game based on different decisions. And what are those decisions? Number of programs printed and different levels of actual sales. Different level of actual sales. Now, we have 10,000 programs. Let's see if we are to produce 10,000 programs and sell 10,000 programs, what will happen? What will happen? Let's see. Let's see how to present this now. Yes. Yes. Print 10,000 program and sell 10,000. Print and sell 10,000. Let me leave it that way. Now, what will be the cost? What will be the cost? The cost will be what? The cost will be what? Let's see. To produce 10,000 programs, there's a fixed cost of what? Of 1 million. We've established that. The variable cost will be what? 400 multiplied by what? 10,000. The total cost will now be what? The total cost will be what? The total cost will be what? What is saying I should start from the probability? From the question, the probability, there's a table there in the question. There's a table in the question that that is showing the program sold, the number of games. So the number of games, the summation of the number of games is giving us 50. The probability of you selling 10,000 will be 5 over 50. When you do that, you have 0.1. Probability of you selling 20,000 programs in 20 games will be 20 divided by 50, 0.4. Probability of you selling 30,000 programs in 50 games will be 15 divided by 50, you have 0.3. Probability of you selling 40 programs in 10 games will be 10 divided by 50, you have 0.2. When you add all the whole probability values, you have 1. So the point now is, when you produce 10,000 programs and you sell 10,000 programs, what will be the profit? We want to prepare a payoff table. But before we prepare a payoff table, let's see the profit that we accrue to the local football club, because it's the profit figure that we'll use in preparing our payoff table. Now, when you print 10,000 programs and sell 10,000, what is the cost of printing 10,000? We've established that we have a fixed cost of 1 million and variable cost of 400 naira per copy. So if you are producing 10,000 copies, what will be the total variable cost? It will be what? And put this in brackets. Word condition. It will be what? 400 multiplied by 10,000. You have what? You have 4 million. You have 4 million. Then 4 million plus 1 million. The total cost will be what? Will be 5 million. Will be 5 million. Let me share my screen so that, let me split it. Faith, please write down your message, your question, please. Or if you're not asking question, please bring down your hand. So the cost is this. What will be the revenue or the sales? The sales will be equal to what? For one copy is 150. So when you're selling 10,000 copies, 150 multiplied by 10,000, you have what? You're going to have 1,500,000. 1,500,000. That is the cost of selling, or the revenue when you sell 10,000. What other cost do we have there? Or revenue do we have? Beg your pardon. It's scrap. But the value of scrap is 0 because everything produced was sold. Let me put it there, 0. That 0 is for scrap. Which other revenue do we have? Advertising revenue of what? Of 800,000. This is constant. Whatever you produce, you will definitely get this revenue. It's a guaranteed revenue. So you have what? You're going to have what? In total, you should have 2,300,000. should have 2,300,000. 2,300,000. Now, looking at these now, are we making profit or loss? Are we making profit or loss? So looking at this, profit or loss, our sales, our revenue, less cost will give us what? For this, the revenue is 2,300,000. The cost is what? Incurred. It's 5 million. At this point, it's very clear that we're making a loss of what? 2,700,000. 2,700,000. Please, always listen to my explanation so that when I ask questions, you will not ask questions of what I've explained earlier. Yes, it's very important. Listen to the explanation, don't get distracted. So when I see your hands up and you ask me a question, you will not be asking me what I've explained before. Yes. So, some of you can be distracted since we are not seeing ourselves. So when you now come back, you now want to draw the whole class back. It's not good. When you get distracted, you just accept your fate that way, and you go and watch the video again. If not, we will not conclude on time. So that is it. So at this point, I've solved for this because I want you to try the next one. I will now give room for question. Don't ask me question on what I've explained before. Let me allow everybody to talk now. Those that want to talk. Well, I know that I'll still get question of what I've explained before. But no problem. Let's hear. Rachel. Rachel, I can see your hands up. Would you?
Okay, good morning, sir. Please, I didn't get the scrap. You said the scrap is 0, and the question I'm not seeing where they say a maximum or a minimum quantity of scrap. I don't know why that scrap is 0 actually, because it signifies that scrap will be sold at 100 naira per copy, and it said it's 0, which means there might be. You said they sold everything, so there's no scrap. So how did we know everything was sold at 10,000 programs?
Now, the point is this. In preparing a payoff table, the course of action is that we printed 10,000 programs. The possibility, these are possibilities, and we're trying to see the profits that emanate from these various possibilities, from the various course of action. So we are now saying that this is a case now of we having 10,000 programs. If we have 10,000 programs and we sell 10,000 programs, what will be the profit? We'll still move again to a point when we have 20,000 programs. When we have 20,000 programs and the demand is 10,000 programs, what will be the profit? It will not be stated to you. Once you are asked to prepare payoff table, you should know that there are two things involved. The printing, that is the supply you have, and the demand. Printing and the and the sales. So in that case, your payoff table, we have two axes, the vertical and the horizontal. But I don't want to present that now. I want to show my workings first. So how do I know that we sold everything? Now, these are probabilities. These are possibilities. Okay, that's should, in case we have 10,000 programs and we decided to sell everything, what will be the profit or loss? We will now still move again based on the various scenarios given in the question. 20,000. If we have 20,000 programs and we sell 10,000, what will be the profit? If we have 20,000 programs and we sell the whole 20, what will be the profit or loss? We'll still move again to the next value given to us in the question, 30. Now, if we have 30,000 programs and we are to sell 10,000, what will be the profit and what will be the scrap value? Because when we are having 30 or 20 and we are selling 10,000, it means we will have scrap value of to the tune of 100 multiplied by 10,000, the value that we didn't sell. Yes. So also, when we move to 40, we will now analyze again. If we should sell 10 out of 40, what will be the revenue? If we should sell 20 out of 40, what will be the revenue? And what will be the cost? Compare, you get your profit. When we move again, out of 40, you're able to sell 30. What will be your profit? And when you have 40 and you sell 40, what will be your profit? So just follow, you get it. But the point is this: when you have 10, 10 is the least value you will have in the question. So it is assumed that we start with 10. And when we have 10 and we sell 10, what is the profit? Now you can have 10 and you have a demand of 20. What will still be your profit? It will still be the profit of 10, because you cannot give out what you don't have. Now you can have a demand of 30, but what you have in your stock is what? Is 10. It means you cannot give out extra 20 because you don't have it. You can have a demand of 40, but what you have in your store is 10. It means you cannot give extra 30,000 programs that you don't have. The sales will still be what? Will still be the value of 10,000, which is 27. So I don't know if this is clear by you.
Yes, perfectly clear. I perfectly understand. Thank you.
So now, if this is clear, if we should have 20, yes, Mr. Shegun, very fast, Mr. Shegun, Dorcas. I think this
Good
will
morning, sir.
All right, good morning.
So just on the same question she asked, just to have more understanding, is it that this selling this demand and this supply, are we the one assuming what we sell, or is it the same demand that we're using to assume what we sold to them? I don't know if you got my question. Hello?
Hello, Madam Dorcas. I think our tutor is coming, but if I understand your question very well, once we have that scenario, maybe this program, so we have to assume we have to print before we can sell. So in a situation whereby we printed 10, we can only sell 10. So if we print 20 and they ask for 10, we'll sell 10 and sell the remaining one scrap. So once they give us one, they will only give us one. you are the one who use the figure they give you to agree what the outcome, what you are supposed to print. Just like if your demand, you use your number of demand to guess what you are to supply. So they will give us number of demand. So you are the one that will now work in line with that number of demand to get what you are expected to supply.
Okay, so we have to work with what we have, what we produce. So that means we'll be selling to them what we produce.
Yes, it's what they demanded. So on that note, you have to be giving it in a case by demanded for 10,000 and you produce 10,000, you will sell everything to them. But paraventure on another day, you produce 20,000. You demanded for 10,000. You will sell the one they demanded. The remaining one, it's either you sell it as scrap. Or if there is no option for scrap, let's say, okay, there is option for scrap in this question now. The remaining 10,000, you will sell it as scrap because your supply is more than your demand. But in the situation where your supply and your demand tally, you sell everything. But if you have lesser supply than your demand, you can only sell what you produce. You can't sell more than what you produce. So that is just the logic.
Oh, sorry, but I'm not saying where they told us that they requested for 10,000. Sorry, maybe I'm the one that is not getting it.
That is probability.
You look at
That's
your
probability.
number of programs
What?
All right.
would
Thank you very much.
10,000.
Mr. Tope,
All right,
Mr.
I'm
Tope,
back.
good morning, sir.
Thank you.
Mr. Tope,
I'm
good
back.
morning, sir.
Good
Good
morning.
morning, sir, Mr. Tope.
Good morning,
Okay,
ma.
sir, my question is based on we are printing 10 games, 10 programs, and sell 10 programs. But they said that number of games is 5 for that 10. I thought we will multiply 10 by 5
No,
to get our revenue because number of games we
no,
sold
ma.
10,000 games, and the number of games is 5.
No, the number of games is the probability of the possibility of the occurrence of those cells. The point is this, man. The 10,000 is not a guarantee that you will sell everything during these games. So these games, this number of games you are seeing is possibility. Is possibility. Is not that 5 number of games multiplied by 10,000 to get your revenue. If you look at the question, the components of your revenue are given, and it is not based on the number of games. It is based on the number of programs that you have to sell. So this number of games put there is just there to get one confused. It is for you to estimate your probability, the possibility of you selling these programs. You understand? In the course of this game. Now, the question that erupted before my network got punctuated, that you are not seeing where 10,000 program is stated that will be sold. Now, the point is this: when you want to make profit, I clearly stated that the payoff table is a table that shows the possibility or the likelihood of profit that will occur. Now, for you to make profit, what will you do? How do you determine your profit? The number of programs you have at your store is what? Is 10,000. The number of demand you have from external customer is what? Is 10. So it's a game of we're just looking at course of action or courses of actions based on different possibilities based on different possibilities. So that is why, for now, this is still a working to show that when you have 10,000 programs in your store or to be given out and you sell the whole 10,000, what will be your profit or loss? So just follow and you see in the question, they will not tell you that this is 10,000, you sell 10,000. You infer that by yourself. That is why I put that video there yesterday that we should watch. So it will not be stated that they sell 10,000 and the whole 10,000 was this. It's different courses of action that the least value now, the least value is 10,000 programs. And when you sell 10,000 programs, what will be the profit? What will be the profit or loss? You proceed. When you sell 20,000 programs, you have 20,000 programs and you sell 10,000, what will be the profit? You have 20,000 programs and you sell 20, the whole 20, what will be the profit or loss? And you have 30,000 requests, but in your store, you're just having 20,000. What will be your profit or loss? So just follow. When we present the entire payout table, I think to be much more clearer. So now, when you print 20,000, when you print 20,000 and you sell that 20,000, what will happen? Well, let me just show this one before I ask you to do one more, to do the next one. Let me show this. When you print 20,000, when you print 20,000, what will happen at this point? What will happen? The cost will be what? The cost element will be what? We have a constant cost value of 1 million plus what? 400 multiplied by what? 20,000. So the total cost here will be what? The total cost here
9 million.
will be 9 million. Now, the point now here is, since this is the maximum we have, we start. If we should sell 10,000, if you should sell 10,000 out of these 20, what will be your profit or loss? If you should sell 10,000, what will be your profit or loss? The point is this: when you sell 10,000, how much is one copy? Is 150 per copy. And when you do that, you have what? 1,500,000. 1,500,000. Now, the 10 that you didn't sell, based on 10,000 cost of action, will become scrap. How much are you paying, or are you getting as the scrap value? Is 100. 100 multiplied by that 10,000 will give us what? Should give us 1 million. Should give us 1 million. Please take note of that. Take note of that. I don't want to do the working to be rough. That is why I don't want to put 10,000 multiplied by 10 to get 1 million. I'm just writing the 1 million direct. Now, which other revenue do we have? We have 800,000, which is a guaranteed revenue. The cost of producing the 20,000 programs, but we only have our opportunity to sell 10,000 is what? The cost of production is what? Is 9 million. 9 million. Now, when you do plus and minus, are we going to have profit or loss?
Loss.
We're going to have loss to the tune of what?
9 million minus 3,300,000. So
Five
we are having loss of
5,700,000.
5,700,000.
So, fine. When we sell 20,000, when we sell 20,000 now, the revenue will be what? Will be 20,000. The revenue will be 20,000. 20,000 multiplied by what? 150. We have it as what? Should have it as 3 million. 3 million. Now, since we are selling the whole 20,000 we have, are we going to have scrap value, income? No.
No.
So
No,
we have
sir.
it as the additional guaranteed revenue, which is constant, is 800,000 minus the costs, which is 9 million. And we have it as what? We have a loss of 5,200,000. So, when we start preparing our payoff table, we'll still have a case where the point is we have a demand of, let's say, we have a demand of 30,000, but we don't have that 30,000. Our loss will still be what? We can only sell 20,000 still at that point. So our loss will still be what? 5,200. 5,200,000. So I'm just showing you this so that when we start preparing the payoff table, you know that is how it's supposed to be. So when you have a request of 40,000 too, and you only have 20,000, what will your profit or loss be? It will be what? It will still be what? Minus 5,200,000. Take note of that, because you cannot give what you don't have. So for when we print 30,000 now, I want everybody to solve this using the approach up there. Print 30,000. When you print 30,000, what will be your possible profit or loss? What will be your possible profit or loss? So I'm leaving this on the screen so everybody solve, and let me get the answers. Alima Ibrahim, any question? Halima Ibrahim, any question?
Hi, sorry, good morning. Thank you very much. But sir, sorry, I didn't get this. We have sell. I guess I'm confused at that side.
And let me know why you're confused.
Yeah, the previous the print 10,000 that we did was just one sale.
Yes.
We did the cost, then we did one sale. Then this
Yeah.
this print of 20,000 now is what I don't understand. Why do we have like two sales?
Yes, we have like two sales because the 20,000 is the maximum at this point now. So there is possibility of we just selling 10,000 out of the 20. And there's possibility of we selling the whole 20,000. So that is why we have those two options. Now, when you have to solve for 30 now, there will be an addition. It will now be you selling 10, you selling 20, and you selling what? 30. So that is how we graduate it. When you now move to print 30 and 40,000, it will now be sell 10, sell 20, 30, and the whole 40.
Okay.
Yes.
Thank you very much. It's clear. Thank you.
Mr. Shegun, I've been calling you since. Abisola. All right, please quickly solve for 30. Let me just see the answers on the message on the chat box. Let me bring down these hands because call them, they're not talking.
Hello. Sorry.
So when we have 30,000 programs now, what will be our profit or loss when we sell 10,000? You can just give me my answer in the chat box. And give me the answer in the chat box. Okay, very good. Dr. Zowolabi, I can see that, yes. The loss is 8,700. The loss is 8,700. Yes, very good. Yes, Ali Grace, I can see that. 8,700,000. Yes, good. Yes, yes, that is nice. Yes. Now, when the sell is 20,000, please excuse me, please. So now for 20,000, when we have 30,000 prints and you sell 20,000, okay. All right, I can see right answers there. 87, yes, correct. Maruf Bamidele, that is correct. Yes, it's fine. Azoro Ngosi, that is correct. Yes, yes, it is correct. Yes. So yes, it's fine. So it's fine. It's so let's now let me just show it on the platform on the slide now for those that might not have gotten it there. So the cost is this. The cost of producing 30 copies is what? Is one of the fixed costs is 1 million plus the variable cost of 400 multiplied by what? By 30,000 programs. By 30,000 programs. So overall, when you do this, you're going to have what? 13 million. Now, at this point now, the possibility of you selling 10,000 out of 30,000 programs will be what? Will be what? So we have it as this, and you sell 10,000 for 150 per program. You have 1,500,000. I want to show the workings. I think I've shown the workings before. Then since you are just selling 10 out of 30, you have scrap unsold of 20,000. 20,000 multiplied by 100 should have should have 2 million. 2 million plus a guaranteed advertisement income of 800,000. And you now less the cost of 13 million, you're going to have what? A loss of 700,000. So now, when you sell 20 now, you sell 20,000. When you sell 20,000 now, your revenue will be what? 20,000 multiplied by 150 is going to be 3 million plus what? Scrap value of 10,000 programs multiplied by 100, going to have 1 million plus a guaranteed income of 800,000 less the costs of less than 13,000 all through, because you've already incurred that cost. That is the reason. So when you have 30 and you sell 30, the whole of 30, what will happen? That is 150 times 30,000 programs. And that should be that should be 4,500,000. We have scrap 0 plus a guaranteed revenue of 800,000 less the costs 13 million. You have what? You have minus. So if you are to, there's possibility of you selling 40,000 programs, but you don't have it, you still have a loss of what? Of 7,700,000. 7,700,000. So I believe everybody in this class should be very fine with this. So now, when it comes to you printing 40,000 programs, what will happen? The cost will be what? Everybody in this class should be able to solve this. I'll call the names randomly. You tell me the cost. Somebody will tell me the cost. Tell me the costs now. Please solve. What will be the costs to print 40,000 units of 40,000 pages? Yes, Doris.
17
17 million.
Okay, good. 17 million. Fine. I'm saying 16 million. There's an error somewhere. Yes, 17 million. So quickly solve now. When you sell for 10,000, out of 40, you're able to sell 10,000. You're going to have what?
5,000.
Okay. So what will now be the profit or loss?
How many were we able to sell?
11,200.
Yeah, 11,700. Thank you. So let's so you can see the breakdown of the question, and this is the major part in that question where it's not clear in the solution in the Pathfinder, and it's been serious headache. So this is the breakdown, and that is how it is. So 400 multiplied by 40,000. You're going to have, there's another method you can use to solve it anyway, but I don't want to present that because that might require me to talk too much. So 1 million plus 400 multiplied by 40,000. So we have this to be 17 million. 17 million. So now, top these, you sell 10,000. The income it will be what? 1,500,000 plus the scrap of 3 million plus the guaranteed income of 800,000 less the cost of production. We have it as what? Minus 11,700,000. When you sell 20,000 out of 40, the revenue will be what? 20 times 150, you have 3 million. Plus, and this scrap will be 2 million. Guaranteed income is what? It's 800,000. Minus 17 million. So we have a loss of what? Minus 11,200,000. And we selling 30,000. Sell 30,000 is equal to what? Out of 40 should be 150 multiplied by 30. You have it as 4,500,000 plus the scrap value to the tune of 10,000 multiplied by 100. We have it as 1 million. And then the guaranteed income of 800,000 less overall cost of producing 40,000 units, which is 17 million, equal to what? A loss of 10,700,000. And when you sell 40,000 units out of the whole 40,000 you produce, what will be the story? Story will be 40 multiplied by 150 per copy, going to have 6 million. Is there any possibility of scrap at this point? Is no. Plus guaranteed income 800,000 less 17 million, which is the overall cost of producing 40,000 programs, and these result into a loss of 10,200,000. Coca Football Club have always been experiencing loss. So now, this is of what we are to present in our payoff table. So now, going to my payoff table now. So this, everything here we've done here is just for us to present in our payoff table. Now, how do we do that? The payoff table, we have four, okay. Right, so payoff table. Now, how do you determine your payoff table? Which item to be on the row? Which item will be horizontal? Which item to be vertical? That is one point of concern. Some students can always ask that question. Now, to correctly structure a payoff table, because I'm explaining, somebody is asking, are we to solve this in less than 30 minutes? It's because I'm explaining. That's why it's taking us long. If you know what to do, you would have finished all this now within the space of 30 minutes. Yes. So, but if I'm too fast, if I finish it within the space of 40 minutes, most of us will not get. It's better I move gradually. So to correctly structure a payoff table, we need to distinguish between what we call controllable factors. That is your decision now. Your decision, controllable factor. That is what decision you want to make. Now, so in this question now, the decision maker is the football club and can choose between the number of programs, that they can likely produce. Now, we have what we call the uncontrollable outcomes. That is the state of nature. That is what might happen in the environment. This is beyond the decision maker's control. In this case now, in this question, the decision variable is how many programs to print per game. This can be determined by the football club. So these will go to the vertical column. Why the state of nature, the demand that you don't have control over. You don't know what quantity can be demanded. You don't have control over it. So that will be on the horizontal axis. So that is how to present this. So we have, let me say, sold. Okay, let me do it this way. Let me bring it here. Let me say sold. And let me have these as printed. Let me say printed. Now, You are likely to have to print 10,000 programs. You are likely let me keep this way. Okay, let me see leave it down. Sold, printed. So we have printed 10,000, printed 20,000, printed 30,000, printed 40,000. Now you sold 10,000. You sold, possibility of you selling 20,000, 30,000. Possibility of you selling what? 40,000. So now, if you print 10,000, this is what you have, 10,000, and you sell 10,000, what will be your profit or loss? It will be, I'll just remove the 3 zeros, please. I'll just make it 27. If you have a request to sell 20,000, but what you have is 10,000, what will be your profit or loss? It will still be 27. When you have a print of 10,000 and a request of 30,000, what will still be your profit? To be 27, because you cannot give more than what you have. You only have 10,000 and people are requesting for what? For 30. So you can only make a loss of 27. And also, when you have 10,000 available, but there's a request for 40,000 units, it means you cannot give that. You are only limited to 10,000. The loss is 27. So also, when you have 20,000 printed and there is a request for 10,000, what will happen? Based on what you've solved, check your answers, the workings, you have a loss of what? 5,700. Yes. And at this point now, the whole 20 you printed is being requested for. What will happen? The loss will be what? 5,200. And also, when there's a request for 30, but what you have is just 20. It means you'll be limited to the loss of what? Of 5,200. Still, same with 40. If you have 20 and a request for 40, you can give what you don't have. The loss will still be 5,200. So also, in this case, you printed 30 and there's a request for 10, means 20 will have wasted. So the loss will be very high. It will be 887 based on what we've computed. Now you have 30 printed and there's a request for 20, 10 will be wasted unsold, and then the loss will be what? Less 8,200. And at this point, you have 30 and there's a request for 30, the loss will be what? 7,700. And at this point, the request is 40, but you have 30, the loss will still be what? 7,700. Now, at this point now, you have 40 in your store, but there's a request for 10,000. The loss will be what? 11,700. Somebody is asking how we're getting these values. We work for them. That is what we've been doing all this while. Now, 20 you have as a request, but you have 40,000 in your store. The loss will be what? Less 11,200. And then you have a request for 30, but you only have 40, and the 10 will be unsold or will be scrapped. So the loss will be what? Less 10, that is minus 10,700. And for 40, you have a request of 40 and you have 40,000 in your store. Means the profit or loss, the loss will be what? Will 10 to 100. So this is the possibilities. Now, what is the expected value now? These are the possibilities. These are the possibilities of this occurring. These are the profits now. Profit now. What is the possibility of this to occur? That is when we now use our probability. We use our probability to multiply everything inside this payoff table now. So the possibility of all this, of we getting all these is what we've seen there. So the probability or the expected value will be probability multiplied by the whole values here. So let's still, let me just copy this. So the expected value will have our probability. Let me say our probability now. Probability. The probability at this point, when we computed 0.1, at this point is what? 0.4. This point is 0.3. This point is what? 0.2. So the expected value will be 0.1 multiplied by all these here. 0.1 multiplied by all these. When you multiply 0.1 by 27, you're going to have what? We're going to have what? 270 for this. All true. This will be 270. 270. 270. Still recognizing the negative value there. So that is what you have to do for all. So you multiply 0.4 multiplied by this. Please type your question in the chat box. You type your question in the chat box, please. So for this, when you multiply 0.4 multiplied by 57, you have what? No, you can do it. You can do it together. I'm just for explanation's sake. That is why I'm just showing it this way. So when you multiply 0.4 by 57, you're going to have what? Please do it. So that you should have 2,280. And for this, you should have what? You should have 2,000. I'm just showing it step by step for the sake of understanding. You can join everything, please. This will be 2,000 and what? Please confirm. Hosts, please confirm these figures, please. Because 2,080 for this. This will be 2,610, and this will be what? It should be 2,460, and this should be 2,310. and this should be it's 2000. So this is what we're expected to do. So the question now is this. The question now is this. The question so this is what they want us to do in the part A of the question. This is what they actually want us to do. The part B. No, I've answered this question. You can just include the probabilities in the first table and do the workings simultaneously. But if that would be confusing, you can just first have your possible values, then you present it the way I've done. You come again and apply your probability to show the expected values. So now the part B of the question. Part B of the question says that what? Prepare a payoff table. Determine the number of programs that will provide the highest profit if a constant number of programs were to be printed for each game. If a constant number of programs were to be printed for each game. So that's the number of programs that will provide the highest profit. The highest profit. Now, based on what we've solved now, which will give us the highest profit? Which will give us the highest profits? Let me hear us. Yes, I mean, yes, it will be the highest loss. In this
one
case
that
now,
will give us the minimal loss.
yes.
Minimal loss is to print 10 and sold 10.
Okay, to print 10 and
which
sell
gave
it.
us 27,000 loss all through.
Okay, okay, thank you. Let's show it now. Let's show it. So on each row, which is giving you the least loss, in terms of profit now, we're trying to consider profit and you're making loss, you go with the value with the least loss. With the least loss, because when you are making more loss, it's a big problem again. So now, in this case, it's a very confusing scenario that you're already making loss. They're not asking you which will give you the highest profits. So it means it's the one with the lowest loss. The program with the lowest loss that will result into. So what they're trying to tell us is that what will be the Maximus decision rule? Maximus. So what's in this case now, for you to interpret Maximus, it means among the loss, which is the least. That is the point now. among the loss, which is the least? Yes. So you can have it as the cost of action, that is for you to print. When you sell rather, that is when you sell, you have 10,000, you have 20,000, we have 30,000, and we have 40,000. So the profits, the maximum profit now. I'm not saying maximum loss, because in terms of loss, it to be the minimum. Yes, to be the minimum, the other way around. So when we have 10,000, the least lost is what? It's 270. When we have 20,000, the least loss is what? 2,080. 2080. The least loss when we have 30 is what? The least loss is 2310. 2310. And when we have 40,000, the least loss is what? 2342. Okay, 2040. 2040. The least. So among these now, which is the least lost is 270. 270 when we have 10,000 programs. So it's a very confusing scenario, because we are not actually making profits, but it's a loss. But the least loss is what will be considered at this point. Is what is to be considered at this point. So that is that for this. So the next point in the question is that explain why you should buy 30,000 or 40 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. I'll need a response now from students. Why should we produce more? Why should we produce 30 copies or 40 copies? Even while the value that will give us, the program that will give us the least loss is 10,000. Yes, let me allow you to speak. Ifoma. Yes. Irene or Irene.
Okay, sir. Since the fees cost there is 1 million, and in printing, the more you print, the more since the cost remains the same, the more you print, the more profit you make. So I feel it's best for them to print 30 and 40,000, since the fees cost still remains the same.
All right. Yes. Thank you very much. Yes, because either you produce less or more, the fees cost remains constant. So is it not better we produce more? It's better we produce more and try to see how we can, as an organization, move away from this loss. As a football club, move away from making loss and try to see how we can take advantage of this opportunity, because the fixed cost is constant. Either we produce one, we still incur 1 million. That will produce 2. So why not produce more to make more profits? To make more profit. So you can read on that in the ICANN Pathfinder. can see what they've put down there. A major concern was that part one. The next is that we should calculate the profits which would arise from a perfect forecast of the numbers of programs which will be sold at each game. Perfect forecast. When you're talking about perfect forecast, it means there was a time you don't know what is happening. You don't have information of the happenings in the market. Now you now have information of what is happening in the market. Now the difference of you having privileged information and the difference of you not having privileged information is what? Is the value of perfect information. In one of the examples we saw during the normal class, we looked at this scenario of you having perfect information, having prior knowledge, and not having prior knowledge. So the difference between when you have privileged information and when you don't have privileged information will result in a perfect forecast. Because when I have information about what should happen, I should maximize that information to my own advantage and make more profit. But when I don't have information and I'm working in uncertainty, I'm working in risk, it means anything can happen. But when I know that this is what should happen, I should be able to leverage on that information and perform better. So now, in this case, the question is saying that calculate the profits which will arise from a perfect forecast of the numbers of programs which will be sold at each game. Now, when you have perfect information, what happened? When you have perfect information, it means you will go for the programs with the least loss. That is, if we are not making loss now, with the maximum profit, it will be the maximum profit. But in this case where we have loss overall, we are to try to see how we minimize our loss. So we're going with the value with the least loss. So because we've computed at this point and we know that this is the least loss, we are to embrace this. This is a case of perfect information. The whole value is here in this case now, because at this point we have 270 as the least, this point 270 as the least, this point 270 as the least. Because we've solved and computed, we know that this is the best option we can opt for. But where we don't have a perfect information, what will happen? Where we don't have a perfect information, at this point, the least is what? 270. At this point, the least is what here? Or rather, at this point, we're working in this scenario. At this point, the least is what? 270. At this point, the least is what? Based on this rule, the least is what? 2080. At this point, the least is what? The least is what at this what? 2040. 2040. Because we don't have information. We just invest haphazardly. We don't have information, so we're not able to maximize the opportunities. So in that case, when you add those figures together, when you have perfect information and you don't have perfect information, where you don't have perfect information, the difference will result into the cost of a perfect forecast. Cost of a perfect forecast, or the profit you have to make when you have a perfect forecast. So please, I encourage you to watch the other video I posted yesterday. We dealt more with that on this in that video. Please do well to watch. And yes, Oluchi,
Sir,
Oluchi,
please,
can you?
I didn't get your. Okay, sir. Good morning, sir. I didn't get your explanation on the question C. Explain why we should buy 30 or 40 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. I didn't get your explanation on that.
Okay, what we said there is that since we are spending a fixed cost for every quantity, irrespective of the quantity we are producing, the fixed cost remains constant. So why should we settle for less while we can produce more? So instead of producing 10,000, we should go for a higher production since the fixed cost remains constant and we are paying more and producing less. So it is justifiable that we produce more quantities and see how we can break even to make profit rather than producing 10,000 and still paying 1 million as fixed cost and still pay that same 1 million as fixed cost. So the point is we should look at maximizing profit and see how we minimize cost. So why should you be paying 1 million as fixed cost and be producing less? Why you have an open check to produce 30,000, 40,000 still pay 1 million as fixed cost. So that is the point there. And I said you can refer to the IGAM Pathfinder to see what they've put down there and add to what I've said.
Hello, sir.
Yes,
Thank
sir.
you, sir.
Hello, sir.
I'm with you,
Please,
sir.
I'm looking at it based on what you said, sir. If you look at the first production, we have minus 27. But if you look at the second production, we have minus 5.2. Then the third production at the same time. If you continue to produce like that, I will not continue to be having higher negatives.
That is making more loss.
Yes, sir.
That you should explain why you should buy 30,000, 40,000 copies, assuming one of these is the most. See the questions are assuming.
Yes, sir.
Assuming one of these is the most. Now they've negated your computation. You understand? This statement have put off your computation, sir. That explain why you should buy 30,000, 40,000 copies, assuming one of these is the most profitable quantity, sir. Are you saying that, sir?
Okay. I'm following a little bit, sir. Yes, sir.
Okay. That when 30,000 and 40,000 copies is giving you, let's say, the least loss now, since we are experiencing loss in this case, is giving you the least
sir.
loss, which in turn will remain as our profit. So why should we not produce more of 30,000 or 40,000 copies and produce less? That you should explain why you should buy 30,000 copies or 40,000 copies, assuming one of these is the most profitable quantity, despite the fact that the most probable sales are 20,000 copies per game. See the assumption there. The assumption now has nullified the fact that you'll be making loss the more you produce. That it is now being assumed that when you produce 30,000, 40,000 copies, that these are the values that will give you more profit. More profit.
Okay.
Yes, that's what there as so anybody in this class that don't know what we've done today, you are here, you don't know what we've done today. You are here. You are here. Yes, I'm with you.
Please, the D part, the calculate the profit which we arrive from a perfect forecast. I understand the explanation of perfect forecast, but the imperfect, the imperfect forecast, how you tell us to do it, I can't, I did not get the explanation. If can you shed light on it? Thank you.
So the imperfect information, or without perfect information. Now, without perfect information means that you don't have prior knowledge of what is happening in the market. And when you don't have prior knowledge of what is happening in the market, you will put your money into investments at risk. At risk. You're putting your money into investments without any period data. You're working based on uncertainty now, based on uncertainty. And when you're working based on uncertainty, when you don't have clear information of what is happening in the market, the loss you have based on this question now, the loss you have when you print 10,000, when you print 10,000, what is the least loss? The least loss. Looking at the row here now, the least loss is what? It's 270. Now, when you print 20,000, you don't have information of what is happening at all. The least loss is what? This row.
2,880.
Yes. When you don't have information of what is happening in the market at all, you will still put your money in any kind of venture, and the least lost here is what? Is
2,880.
Still, when you don't have information of what is happening in the market, you still go for this. The least lost is what here? 2040. But when you have information of what will happen in the market, when you have information of what is happening in the market, you will not go for the least. You go for what will maximize your profits. You go for what you get the best returns on. So the results without perfect information based on the various course of action will be 270, 2080, will be 2310, and will be 2040. When you don't know what is happening, you just print. But when you now know what is happening in the market, you go for the opportunity whereby you minimize cost and you maximize profit. The two is the difference between the two is the costs or the benefits of getting information. Now, somebody is asking, how do we get the market information? You get the market information based on what you've computed. Now, based on what you've computed, you look at it that when you print, what is the best profit? What is the best profit when you print? What is the best profit when you print? Now, when you don't, the best profit when you print, that is after presenting this table, the best. Now, before presenting this table now, there is result without perfect information. Result without perfect information. In this case, you look at the row, the values in the row, the least values on each row, the least value on each row. Then against the demand, what you decided to sell in terms of column. Now, what are the least values in terms of column? The difference between the least values in terms of row and column based on the least profit, or the least based on the maximum profit. But in this case, it will be the least profit, the least loss rather. Then the difference between the two will give you the value or the benefit of obtaining information, the price you have to pay to get information. So please, the more example on this is in the one we solved in class. Madam Dolapo, I don't know if you
Yes, I'm trying to get it. I think I watched the video yesterday. So I watched back and watched the video very well. Look, from what I'm getting now, is that the minimal regret is the same as the result of having what is it called? Information. Sorry, can you please mute yourself if you are not talking?
okay. Okay, Mark, can you speak on please? Yes. Madam Dolapo, can you speak on?
Okay, I said from what I think, what I don't know, I stand to be corrected. From what you have explained, does it mean that minimal regret rule is the same as the result when you have perfect information in the market? Because the way this one is negative, is somehow throwing me off. But when I watched the video of that yesterday, I think I have to go back and watch that video that you posted yesterday, because that's resulted in profit. So I'm just trying to differentiate between this minimal regret and the perfect information. Is there any correlation between the two?
There is no correlation, ma. Minimal regret is you getting the highest in a column and subtracting every other element from that maximum value. That is a minimal regret. The maximum in column, maximum here, you subtract every other element from the maximum. Maximum here, that is minimal regret. Then you now work based on row and pick out the highest based on the maximums, and that is minimal regret. Of a perfect information, what is the perfect state? The perfect state, the best possible outcomes before you compute this, and the best possible outcome after all these have occurred. But in this question, there are little information about the perfect information. But the point is this: the results without perfect information, when you don't have perfect information at all, what do you do? What do you do when you don't have perfect information? When you don't have perfect information, you decided to print 10,000. You made a least loss of 270, which is the best you can experience. When you don't have perfect information, you printed 20, you made the least loss of 2009, which is the best at that point. When you don't have perfect information, you printed 30 and you made the least loss, which is this case is the best, 2310. When you don't have perfect information, in this case you printed 210, you made the least loss of 2040, which is in this case the best. But when you now have perfect information, when you now sell, now, what are the least values when you sell? What are the least values now? Looking it downward now from these cells, the least values, which are the best losses in this case. When you compare that, when you compare this, when you have perfect information with when you don't have perfect information, then you have the benefit of having perfect information. The benefit of having perfect information.
So sir, the result perfect information will be 270 all through.
Yes, because they are the best options. Yes, based on when you sell. But when you are just entering the market and you don't know what to do, what are the best options based on each column? You understand?
Sorry, sir. Okay, I understand that now. But in a scenario whereby we were giving profit, we arrive at profit, the perfect information will be the highest profit.
Yes, ma'am.
Okay.
Highest profit.
Why would the perfect information be below the least loss or the least profit? Is okay. Thank you so much, sir.
All right, I have been seeing these hands of yes, Irene.
Okay, sir. Based on what Madam Dr. just said, please, I would just like us to use this second row and second column as an example, just to be sure that we got it right. So, in the case where we have perfect, perfect information now, for the printed copy, that's 20,000. Then the least loss will be 2,080 naira. But where we don't have perfect information, the least loss will be 2,000, would be 270, right?
No, where you have perfect information. Okay,
Okay,
yes.
sir.
Yes. Where you don't have perfect information, you understand? You make the highest loss. You understand? But when you have
Yes.
perfect information, you make a least loss. You understand?
Okay. When we don't have perfect information, we make the highest loss.
Yes.
And when we have perfect information, we make the least loss.
Yes.
So which one is now who's talking? Oh, God. So which one will now represent, how will it now be represented?
Yeah, I'm trying to mute this person now. So this is it. Let me just show it and make it now this is it. before the result without perfect information. When you don't have perfect information, what is the least loss? When you don't have perfect information, when you don't have perfect information, the least loss, this is it. When you make a print of 10,000, the best, which is this, you look at it in form of the rows now. Let me make it this. The list here is what? Let me insert another. Let's go to the right. The list here is what?
270.
270. And also, in this point, in this case, you don't have perfect information. You just printed. You don't have perfect information of what will happen in the market. The least lost here is what? In this instance too, you don't have perfect information. The least value is what? That is the best now. That is the best that can occur. The best that can occur. In this instance, you don't have perfect information. You look at it in this form, row-wise. You look at it row-wise.
20.
You don't have perfect information to be what? 2040 without perfect information. Now, with perfect information, that is based on what you sold now. Take note, based on what you sold now. With perfect information, we look at it. We look at it in terms of column now. Based on what has happened, based on the sales that have happened, with perfect information. You look at it in column with perfect information. With perfect information.
Excuse me.
Yeah, speak on, I'm with you. So with perfect information now, based on what you giving out, you look at it in this form, column. What is the best here?
270.
270. Based on 20,000 units given out, what is the best here? What is the best here?
270.
Based on this, what is the best here?
270.
Because you have the knowledge now. 270. What is the best here?
270.
Is it not 280? Is it not 280? With perfect information.
The priest. The best here is what, sir?
280 now. Why is it 270? Sorry, 240 should be there. Now why is it 270?
Okay, sir.
40,000.
You know, this is loss now. What is the best loss? Not the highest loss.
Minus 270 and this 240, is it not lesser than 270?
Now we're looking at it in terms of loss. You know, the minimal loss. The minimal loss now is better off than
That's 2,014 naira, not 240.
Okay, sorry. Thank you. Sorry.
So now, please, the difference between this and this will give you the benefit of having knowledge of what is happening in the market. That is the value of a perfect information. The value of a perfect information. So please put your
Sir, my
question.
hand, I've been raising my hand since, so
Okay, so please sometimes you put your question in the chat box. You know, if it is what others can respond to very fast so that they can, you know, some of the questions I see, some are questions that Olaoye, time is going so that I can close the class.
hello, please,
Good
sir.
morning, sir.
Yes.
Good morning, sir. When you're explaining concerning the table, you said the way we will know where production will be and where the sales will be. You said something about control. I didn't get that part, sir.
Okay. I said, okay. I put forth that to correctly structure a payoff table, that we need to distinguish between decisions and state of nature. So I said decisions are what you can control. You can control your decisions. So these are controllable factors. You understand? And what you cannot control, the uncontrollable outcome, are the state of nature. Things like the quantity you will sell, you can't control it. You understand? But you can control the quantity you will print. It's a decision that you have to make by yourself. So that is what I said about that. That for you to know what to be on the vertical axis is based on the state of nature. That is the horizontal axis now, the state of nature, which is in this case sold, because you cannot determine the quantity that you sell, while the vertical axis is based on the programs to be printed. So that is what I've put forth regarding that.
Sorry for interrupting. You have sent my question in the chat box. I'm still confused about the B part of the question, please.
Okay. What is the B part saying? Determine the program that will provide the highest profits if the constant number of programs were to be printed for each game. Yes, anybody to explain? Yes, the B parts. Yes, anybody to explain? Yes. Madam Dolapo, can you speak on?
I said that if that one is telling us that we should look for Maximus decision rule, the one that you have the best outcome, the best of the best. So from what we have here, the best of the loss is 270. So for you not to incur loss more, you have to produce 10,000 units and sell that 10,000 units so that your loss will be minimal.
So the question says, determine the number of programs that will provide the highest profit. But in this case, we are all making loss. So it is the least loss that will suffice as the best situation at this point. So that is why among the arrays of losses that we have in our computation, which is the least, which is better off, is 270. And that is why the best, the maximus is 270. So it's an opposite something now in this case, because we are not actually making profit, but we are making we are making loss, but among the loss we've made, which is better off? Which is the least? And it's 270. So that is taken as the maximus, as the maximus. So you see this profit in an inverse, this loss in an inverse way. That yes, I have a loss of 2040. I have a loss of 270. Which loss is better off? It's 270. So I opt for 270 as my maximus, which is the best, the maximum among the various maximum options. So that is maximus for you. But this case, if you don't understand the concept of maximus before, using this as an explanation can be confusing. So you can read more about maximus. Please visit the ICANN study test. It's well explained there. Then you watch the video forwarded yesterday to consolidate on the knowledge of maximus. Then you will now be fine. Thank you. Mr. Charles, what is your question? We are going to less the total. Let me see the questions in the chat box. I have shown it via the table. Are we to add the values for without perfect info and subtract the summation of the yes, result with perfect information. Result with perfect information. So we are supposed to less the value of without perfect information from perfect information. Yes. So we're supposed to deduct that value. So when you deduct, let me go back to the table now. Let me go back to the table. Okay, so when you add all this, the result is what? When you add all this, the result is what? Will be 700. So with perfect information, the result is what? With perfect information, 1080. 1080. So all things being equal, the result with perfect information should be better off than when it is without perfect information. So it should be 1080 minus 6700. When you do that, well, 6700 is already having negative. So it will now be what? It will now be, this is minus 1080 minus 67. So it will be what? It will be 1080 plus 67. 1080 plus 67. So that will be the results there. That will be the result there. Yes. So, Mr. Charles, please, where is your question? I'm not seeing your question. And we've answered it, that the B part is still a bit confusing. It has been answered. Vivian, can I see your question in the chat box? Vivian, can I see your question in the chat box? Yes, let me see your questions, please. It means you are raising your hands in error. So class, I can't play your videos. Yes, you don't have your Gmail open on your phone. That is why. You don't have your Gmail open on your phone. So activate your Gmail on your phone and you'll be able to play the videos. Yes. So that you have it in your phone. Okay. All right. Just relate with me after the class. Let's find a way around it. So that is it. So no problem. Just relate with me on WhatsApp. We'll talk about that. So Mr. Charles, you still want to talk about the B parts. So you can speak, Mr. Charles.
All right, thank you, sir. Okay, my area of confusion in the B part is where you have, let me read the entire question, determine the number of programs that would provide the highest profit if a constant number of programs were to be printed. So my confusion is from if a constant number of programs were to be printed for each game. I don't know how to interpret that.
Okay, that's if a constant number of programs are to be printed for each games. For each games. Now, if a constant number of programs is to be printed for each game, there is no issue. But how many did you sell? It is the sales that matter now. It is the sales. It is the sales that will determine your profit. Yes. You can produce a program and there is no sales. It's zero. So it is the sales that will give you, that will determine the profit you are to determine. So where there is even a constant programs produced, you produce 10 and you sell 5. What is the profit? You produce 10 again, you sell 6. What is that profit? You produce 8, you produce 6, you sell 2. What is the profit? So it is the profit element that we are concerned with, and that is why we've picked that from what we've solved. Yes. So the number of programs produced is not a determinant of our profit. It is the sales that is a determinant of our profit. So that is why the constant program is undermined.
So I get it now. Thank you, sir.
So class, I'll send this slide. Tomorrow evening we'll meet on activity-based costing. I will send a video on transfer pricing and divisional performance to the group. Transfer pricing and divisional performance to the group. And the questions, I think I saw one of the past questions there. Then I will send another past question still on transfer pricing and divisional performance to the group. So please, let's do well to watch and see how we can go, how far we can go. Then after activity-based costing, I trust God that we'll look at variance analysis. Variance analysis. Though officially my own part is supposed to end on Sunday, but I will not conclude till I treat some other topics, God's willing. Yes, maybe by next week, I'll treat some other topics and questions. I will still look at maybe cost volume profit analysis, and let's see how it goes. But please use theory files I forwarded. Please do well to go through them. You will definitely see questions from there. Please do well to go through them. You mustn't commit your resource and your time to this and come back for this course. That will not be our portion. So please, let's do well to put every effort in place. Don't leave any stone unturned. Do all your best, and let's move to the next level. God will help us. Let's have a pleasant day.
Hello, sir. Thank you, sir. Sorry, sir. A quick reminder, sir.
I'm with you, man.
You promised us sometimes that these question facts that have yes, yes, yes. I just want to remind you that
I saw that message on the platform, but I didn't remember promising you that. Ma, if you have issue with the question, call me. It's a very simple thing. I'll discuss it with you, ma.
It's okay. Thank you so much.
All right.
Hello, good morning, sir.
Yeah, good morning, too.